Grade 12 learners, you will realize that when you tap into question 3, it will be a continuation of sequence and series. Because question 2 was based on quadratic sequence, it then means that question 3 will then look at arithmetic sequence or a geometric sequence, and this could also be a series in many cases. And if we look at this question, really, it is going to focus on an arithmetic sequence and series. Now, to read this question, it says then to us that consider the given series. So here we are given a series. And we can see that this is a series because it has a sigma notation. So this is to say that we are adding terms here and this becomes a series. Now, remember I said on question 1 that when we use the word consider, it means that we must analyze the question that we're given or the problem that we're given. So in this specific question, it means before we can attempt answering these questions, we really have to analyze this sigma notation. Now, when you look at this sigma notation, you can see that it has the form of a plus I minus 1, open bracket, close bracket, times d. So this has the same form. So this would be the a, which is the first term really, and this will be the I, because we are using our lower bound or the start point as an I, and we subtract by a 1, and this here would be our D, our common difference. You have to be really able to see that pattern or that formula within this sigma notation. Remember that this part here stands for the general term, starting with the I or the variable that they use at the lower bound. And the other thing to note here really is that this sequence ends at some number j. That will be our last term there, j, but we don't know what it is. Probably something that we're going to calculate in the question. So at this stage I've considered this, and obviously when you look at this form here, one can see that this really, it is an arithmetic sequence. You can see that this is an arithmetic sequence because this is the general formula of an arithmetic sequence. So this is an arithmetic sequence. Let's try to answer then the questions. Question 3.1 says to us that we should write down the first term of the series. We just said that the first term is equals to a and is equals to -1. So this is a very simple question to actually answer question 3, and we're looking at 3.1. We're saying the first term is equals to a and is indeed equals to -1. Now, there are other ways in which one can solve this. As you know, there's a common saying in mathematics where we say there are many ways of killing a cat. One might want to actually expand this by putting the 1 here and finding the value of the first term. You will find that will give you -1. And if you put a 2 here, you will get the second term, and so on, and the fourth term. You can do it that way if you like. But in this specific case, you can see that this is only 1 mark, and really you don't have to waste time expanding, doing the expansion of that sigma notation, because you can see from this form that this is an arithmetic sequence. Now, the second question, 3.2, asks us to say what type of a series is this. Then they need us to justify the answer. Already we said that this is an arithmetic sequence. So this is an arithmetic sequence, and the reason for that is because there is a common difference. There is a common difference of 4/5. How do I know that? Because I said the D here would be the 4/5. Again, another way would be you expand this by putting the 1, the 2, the 3, and you get the terms here. You get all the terms here, and then you do the difference in between those two terms, or the successive terms if you like. Then you will be able to get that common difference of 4/3. But there's no need, because you can really see it from there. Now, the question that follows this, 3.3, they say the last 3 terms are such that we have the sigma notation of the same general formula, and it's giving us 71 2/5. But now the thing here is that we start at k is equals to 31 and we end at j again. So you can see here that from k is equals to 31 to j, whatever j is, even if you don't know what j is, the last term would be there. We know that this is the sum of the last three terms. In other words, they took the last three terms and they added them and they get this number here, right? Very important to notice that. So what I'm going to do is that I'm going to say in this question is that so if we look at 3.3, we are saying that we're having a sigma notation of, if we are on term 33 and we add the terms there, we end up with, so this is a j, we end up with the sum to be 71.71 over 2 over 5, and this ends at j. So I will say here that the number of terms from k is equals to 31 to j, the number of terms, I'm going to use a different symbol here, which I'll call m, is going to be 3, because we are told here that the number of terms here, there are actually 3 of them. The number of terms are 3. So what I'm saying is that if I say the upper bound minus the lower bound, I should get 3 plus 1. You know that formula where we say can I use a different color here perhaps to make my point? If we say here that, so I'm saying m will be given by, remember m is the number of terms, the last 3 terms here. In this specific sigma notation is going to be the upper bound, which is a j minus k, and then we add a 1. Remember, you will say this minus that plus 1. That's how you get the number of terms here. And I'm saying the m here should be a 3, because we are told that, you know, the terms here, the last terms are 3 actually. So the last terms in the sequence are 3, and they add up to that number. So now let's try to answer then the question. They then say on question 3.3.1, determine the number of terms in the series. Now look at this. Here they want us to determine the number of terms when I is equals to 1 to j, meaning the number of terms for the whole series, right? And we are given the last 3 terms there. Now there are a lot of ways in which one can do this. This is a really open-ended question. There are many ways in which one can really do this. So we are on 3.3.1. And to actually do this, I can come here and say that the number of terms, the last 3 terms are given by j minus k. So what am I doing? I'm using exactly the same formula that I wrote here. J, the upper bound, the upper limit, minus the lower limit. And we have to add a 1 here. And what is going to happen really here is that I know that m is 3, because these are the last 3 terms. And I'm going to say this is equals to the j, I don't know, but I know that the k is actually 31 plus a 1. And really from here, one can see that the j will be equal to, I'm just going to jump straight to the final answer. So here I'm going to have a negative 30. If you take the negative 30 to decide to add the 3, is going to be 33. So the j here now, I found it to be a 33. Now, if I want the number of terms for the summation, remember we're looking for the number of terms from I is equals to 1 to j, meaning for the whole series, not only the last 3 terms. Remember here we just found the j here in these 2 parts of the series. So if I were to really look at the number of terms for the whole series, for over 5 here, for the whole series, I'll then say the number of terms n is going to be equals to j minus I. So I'm saying the number of terms for the whole series is going to be the upper bound minus the lower bound plus 1. And what is going to transpire here is that we already know that the j is 33 because we calculated that here. And we also then know that we are starting at I is equals to 1 because the I here is equals to 1. And we are adding a 1. And therefore, this means the number of terms is going to be 33. So here I made a mistake, should be at 33. So the number of terms is going to be 33. That's one way in which one can really do this question. And again, if you look at this question, it's only 2 marks. So this means that with this question, you'll get an answer for the final answer, and also computing that part of J there. Now, I want to share with you another way in which you can break this question down. Just to share, I'll only share 2 ways. I mean, I think there are about 4 or 5 ways in which one can do this, but I'll share the second way because I think it is really, really, really inspired. So another way of looking at this series really is to say that the sum of I from 1 to j being equals to -1 plus I minus 1 times 4 over 5 is really the same as breaking this series into 2 parts, where we're saying we are having the sum from I is equals to 1, where we start with, here we have a -1 plus I minus 1 times 4 over 5, and we are adding this to the sum of, so here we said k is equals to a 30. No, this is k is equals to 31. So it means if this is 31, so here it means we'll be at 30. So we're going to have k minus 1, meaning if I say k minus 1, if I say 31 here minus 1, I should get the 30. And this should make sense to you, because if I'm moving from 1 to a 30 and we're saying this is 31, this is what we were told in the question. We were told that this here is 31. It means the previous term here should be a 30. So here we move to 31 to a j, we end up at j, and then we're still having -1 plus I minus 1, 4 over 5. So we are basically, if I add this section from 1 to 30 and from 31 to j, remember we don't know j, we're trying to find n then. The sum of these 2 series will give us the sum from I is equals to 1 to I is equals to j, the last term there, which we don't know in the second method that I'm trying to use. So this means that if I'm looking for n, I can say that n is given by, I'm going to focus my attention on this first part here to say the upper bound, which is k minus 1, minus the lower bound, which is I. So I'm going to say minus 1 plus 1. Remember, we are always saying the upper bound, k minus 1, minus j, minus I. So this is I here, minus I, and then we're adding a 1. I think you should remember this formula, you should know this formula. But in this case, I'm then going to say, because I'm looking for n, meaning n here, for the whole number of terms from I is equals to 1 to j, it then means I also have to add the number of terms that we have here. And in the question, we were told that the number of terms here there is 3, and we said this is m. Here we said the number of terms here is m. The last 3 terms that are called 3, that are given as 3, is equals to m. So these are for the last 3 terms here. So this is how I'm going to construct my formula. I'm going to say here the number of terms here, which is this part here, plus the number of terms here, which is m, we know that is a 3, should give us the total number of terms for the whole series. And in fact, now this would then come down to the fact that k minus 1 is a 30. So here I'm going to have a 30 minus j is a 1. We know that j is a 1 here, plus 1. And we're saying the last 3 terms here, m is going to be 3. Our m is equals to 3. And you can clearly see that, this would be a 33, because these 2 would cancel out, and you're having a 30 plus 3, and you should get a 33. I'm going to stop here. As I said, that there are about 5 ways in which one can do this. I want to leave it here for you to explore any other ways in which exist. But I will also share with you on the memo the other ways in which one can do it. And feel free to use any method that makes sense to you, that's easy for you to really employ. Now, again, this question will be marked out of 2 marks as well. And if you use this method, really, you would find that they will give you a mark for constructing this formula and finding the final answer there. The fact that you're able to see this relationship here from the formula. Now, question 3.3.2, it then says to us, hence or otherwise, determine the sum from I is equals to 1 to k minus 1 plus from k to I of this series. Again, as we said last time, we said that when you see the word hence, it means you use what you have done at the top to then find the answer here. Otherwise would mean you can use any other method without actually using what you have done at the top there. Now, to answer this question, we'll focus as usual on the hence, as I advised last time in the previous question to say when you use the hence part, it becomes easier. So if you look at this sum that they want us to do, it actually looks familiar. We have already constructed this here on our answer to say if you add these terms from I is equals to 1 to I is equals to k minus 1, do you see that? I is equals to 1 to k minus 1, and you add then the second part, which starts from k to j, which is this one here, k to j. Then this is the same as finding the sum of the whole series. Is the sum of finding the series from I is equals to 1 to j. And you would see that, if k is a 30 here, you must remember that k is a 30. So if this is a k, this would be 1 less than k. So it means we're going to subtract 1 from the k, and then we're going to get the 30 there. So this actually is the same as finding the sum for the whole series. It's the same as finding the sum for this whole series. Now, there's something very interesting that you have to observe here in order for us to answer this question and to make it to be really easy. So here we are looking at 3.3.2. We are saying that we are looking for the sum of I is equals to 1 to 33, because our j we now know that is a 33, and this is 1, this is I minus 1, 4 over 5, given by that. Now, there's a couple of things that we have to understand. Our n is equals to 33, so we know that there are 33 terms in this sequence. Our T1 is equals to A is equals to -1, we know that, and the common difference is equals to 4 over 5. This means I can use the formula that says the sum of the terms is equals to Sn over 2, 2A plus n minus 1 times a d. And I have all these variables in there to find the sum. So this means then now I will say S33 is equals to 33 over 2 times -1 plus 33 minus 1 times 4 over the 5. And this would then give me, we can pull a calculator to do this math. So it's going to be 33 over 2, and here I'm going to have a bracket. I'm going to have a 2 times -1 plus 33 minus 1 multiplied by 4 over 5, and this indeed gives me the sum of 389.4. So that is the sum of 389.4. Alternatively, what you can do is that you can find the sum from 1 to 30 and add that to the sum of from 31 to 33. But the nice thing is that if you do that, you would say here that S33, just to break this down, what I'm saying is that you'll say S33 is equals to S30, because we're moving from 1 to 30 here, plus the sum of the last 3 terms. So I'm going to say S3 here, because it's the sum of the last 3 terms. Then the answer that you get here for the sum of the first 30 terms, you will add to it the sum of the last 3 terms, which we know that the sum of the last 3 terms is 71.2 over 5. Please try that method and tell me what answer you get. You can always check on the memo as well if you're having problems, or leave me a comment in the comment section. I'll be able to assist. Now, the last question in this question is 3.4, which says to us that if S71 is equals to 1,960 S7 and S70 is equals to 1862. Determine T71. Now, this is a very simple and interesting question. So we're looking at 3.4. So in this question, we are told that the sum of the first 70 terms of any sequence is 1907, and the sum of the 70 terms are really equals to 1862. Here we are going to use a formula that if you want to find the term, any term using the sum is going to be Tn is equals to Sn minus Sn minus 1. So what I'm doing is that the sum of the nth term minus the sum of the terms that are one less the previous term is going to give you that term number. So here I'm going to simply do a substitution of what we have, because remember we are looking for term 71. So this would mean that I'm going to put 71 in place of n, because we're looking for term 71. And you can see here that this would be S71 because our n is 71. So we're going to have S71 minus n minus 1. Remember, this is 1 less the previous term. So that means if we subtract the 1 from 71, we get a 70. So it's going to be the sum of 70 terms. But we have all these numbers. The sum of the first 70 terms is given by 197 minus 1862. And when you do that math or that operation, it should give you 55. I get a 55. So the 71st term would be a 75. Now, I hope you enjoyed this question. It was very nice and interesting. Stay tuned for question 4.